Hey 11s, this is exercise 5D on one-to-one functions and implied domains on page 188 of your textbook. Now there is some content I'd like to cover from exercise 5C that we didn't because I skipped over 5C given that a lot of it is stuff that we already know. But there's one bit which is the definition of a function versus a relation. So a relation is a general term, something we talk about when it's kind of like an expression when we have an equation, an equal sign involved. But a function is a type of relation such that for each value of x, there is only one corresponding y value. Now, your CAS calculator can't put in relations that aren't functions. So, for example, if you had x squared plus y squared in your as a relation, you couldn't put that in the class pad. It likes a function. For each x value, there is only one corresponding y value. In other words, a function cannot contain two different ordered pairs with the same first coordinate. If you remember our arrow diagrams, if I have my x values on the left and the y values on the right, if I have a value of 1, it has to go to one point there. It can't go to two separate points. What I've just drawn now is a relation and no longer a function. So a function has one corresponding y value for each x value. And we can do something called the vertical line test to visually describe this. So a vertical line can be drawn anywhere in the graph, and it only ever intersects the graph at a maximum of once, then the function is the relation, is a function. So we can see in this example on the left-hand side, no matter where I was to draw a line here, a vertical line will always give me one intersection between these graphs, between the graph and the vertical line test. Whereas if I do something like a circle, you can see that it intersects twice. Okay, that's because for one x value, it gives me two different y values, and therefore it's not a function. In the same vein, we're looking at the idea of one-to-one functions, which is a function if it has different x values mapping to different y values. Basically, all that's saying is that I'm focusing on the idea that if a horizontal line can be drawn anywhere in the graph of a function, and it only ever intersects the graph at a maximum of once, then the function is one-to-one. Basically, it's just saying that if I have a certain y value, I can only ever have one x value to get to that value. I know it's a lot of jargon there, but let's go through and demonstrate what it means visually. Over here, you can see that if I was to draw a horizontal line between, let's say, this point here or here or here, wherever it is, you see that there's only one intersect between the horizontal line test and the graph itself. Whereas if I do it for something like this, you can see that it intersects twice. What it's saying is that for the same y value, I'm going to give it a random value, let's say y equals 9. For the same value of y equals 9, x could be either 3 or negative 3. And so therefore this function is not a one-to-one function. The graph on the right, you can see that if I keep going here, it will have a single intersect, meaning it is a one-to-one function. Even if you consider a line straight across here through the stationary point, remember the stationary point doesn't mean it flattens out and stays there. It means it flattens out at a certain point and comes back up, which means there's still only one intersect. Now, ultimately, all this culminates to trying to draw a graph, understand the idea of those graphs and where there are certain restricted domains. Hopefully, remember the implied domain concept from before. So we have to state the implied domain or the maximal domain, sketch the graph, and find the corresponding range of this function. Now, I do want to say that for this function over here, remember that implied domain, or actually applies in general, but implied or maximal domain is the set of all real numbers for which the rule of the function has meaning. If I have a function like this, now we haven't actually tackled equations like this in the past because it's more stuff that we covered in chapter 4 and we will cover in chapter 4. But in this situation, we can look at this and say, well, I know that 1 over 0 is infinity. It doesn't exist. It's not defined, right? So we're saying that the rule of the function doesn't have meaning when the denominator is equal to 0. And so if I was to write that out, I know that the denominator, 2x minus 5, cannot equal to 0. If I was to rearrange it, plus 5 on both sides, I get 2x cannot equal to 5, and ultimately x cannot equal to 5 over 2. x cannot equal to 5 over 2. If I sub in x equals to 5 into this equation right there, I would end up with 1 over 0. And therefore my function doesn't have meaning, and I want to make sure it does. So I can say that my implied domain equals to all real values of r, and sometimes you will see it written like this. All real values of r, set difference or excluding the sample of 5 over 2. 5 over 2. So that'll give us all real numbers except 5 over 2. That's implied domain. Now, if you were to sketch this graph into your calculator, you would get a function that looks something like this. Like I mentioned, we haven't done this by hand yet, or learned to do this by hand, sorry, so don't stress about not knowing the shape of the graph. For now, just know how to sketch it into your calculator. We'll get a function like this. Now, ultimately, of course, we know that x cannot equal to 5 over 2, so that value right there is where x equals to 5 over 2. Purely looking at this, we can see that the corresponding range of this function, we're thinking, okay, well, the range is what values of y can this function take? It can take all values of y except where y equals 0, because remember, there is an asymptote here. Well, at least we can see that from the graph. We can see there's an asymptote there because y cannot equal to 0. 1 divided by any number, if you think about it that way, 1 divided by any number, it doesn't matter how big or how small, as long as it's not 0, 1 divided by any number cannot equal to 0. Y cannot equal to 0. I could have 1 divided by a million, it'll still give me 0.000 blah 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 all the way, but it wouldn't give me 0. And so therefore I have y equals 0 as an asymptote because I cannot reach y equals 0. And so therefore my range is all real numbers barring 0. Hopefully that makes sense. Let me know if you have any questions.